What's up everyone, myself Aditi, and today I'm back with LeetCode's another daily challenge problem. So in this video, we are going to solve question number 779, that is kth symbol in grammar. So we have to build a table of n rows, which is one indexed, and we start by writing 0 in the first row. Now in every subsequent row, we look at the previous row and replace each occurrence of 0 with 0, 1 and each occurrence of 1 with 1, 0. So basically in this question, what's happening? We are given a binary pattern and it is represented as an infinite string of zeros and ones. Okay. So it's generated as follows. First of all, we have to start with a single 0. Okay, like in row 1 we have to just start with writing 0. Okay, then for each subsequent row we have to look at the previous row and we have to replace each occurrence of 0 with 0, 1 and each occurrence of 1 with 1, 0. For example, if you start with 0, the next row will be 0, 1. Okay, why? Because in the first row, since it's just 0, in the second row you will replace the value of 0 with 0, 1. Okay, now in the next row, what are you going to do? You are going to replace value of 0 as well as value of 1. So in third row, your actual value will become 0, 1, 1, 0. 0, 1 for 0 and 1, 0 for the 1 which you wrote in row number 2. Okay, so in this question, your task is to write a program that given an integer n and a positive or a position k, we are asked to return the value which is 0 or 1 either in the kth position of the nth row, which is 1 indexed. Okay. Okay, so let's first of all understand the question better with the help of example given. Okay, example 1 says you are given two inputs, n is 1, k is 1 and output is 0. So let's see the diagram or the drawing, you can say. So first of all, in this question, you are given two inputs, okay, or two parameters, which is integer n and another is integer k. In example 1, it is given n is 1 and k is 1. Okay, so n is the rows number, that is n is equal to 1 and then n is equal to 2 in the second example, and this is something that I've taken by myself. Okay, so I hope it's not given, so it's not given in the example. Here consider n is 1 and k is 1. So basically when you write n equal to 1 as given in the question clearly, you just have to start with a single 0 in the first row, that is, it's clearly written the first row is 0. Okay, so I wrote n equal to 1 I just wrote 0, and then n equal to 2 I am just replacing the value of 0 with 0, 1. So I am just replacing it with, in place of 0 I wrote 0, 1 altogether. Now when I move to the next row, you can clearly see I have since we are asked to replace both values, that is of 0 with 0, 1 and occurrence of 1 with 1, 0. Okay, so here the value of 0 is replaced by 0, 1 and the value of 1 is replaced by 1, 0. So I hope it's clear till now, and you can clearly notice one thing as we increase row by 1. Okay, like we move from 1 to 2, and when we move from 2 to 3, you can clearly see in row number 1 there was only one element, in row number 2 there were two elements, and in row number 3 you can say there are 4 elements or 4 positions of k. So you can see the number of positions or the number of elements in each row are just getting doubled. Like this is 1, this is 2 and this is 4. Okay, now consider this question or this example, because this is the example by which or with the help of which you will be able to understand the whole implementation of the program. So consider n is 2, k is also 2. Okay, for this particular example you can clearly see n is 2 and they are asking you the value when k is at 1 position. Okay, so you will return 1. Okay, but when n is when k is 1 you will return 0, but when consider this example, n is 2, k is also 2. So in this, first of all, what are you going to do? You can clearly see this is the first position, this is the second position. What does that mean? That simply means when you are at 0 or when you are at the first position, that means you are at odd position. When you are at even position, you are having the value as 1. Okay, so here first of all, what are you trying to do is you're finding the kth position when you are given k as 2. Okay, so here you can clearly see the number of elements in each row is the half of number of elements in the previous row. Okay, or the next row, you can say. So here there are 4 positions, here there are 2 positions. So for k equal to 2, what are you going to get? Here you will be having half number of elements, so you will simply get 1. Fine. So when you have k is equal to 1, you will recursively call for another subsequent rows and you will have calls for n minus 1 and with the integer k. Okay, here you will have simply 2 minus 1, that is 1, and then you will call it with k is equal to 1. So you can clearly see here when n was 1, you simply had one element in the row, that was 0. So this is nothing but our base case. Okay, this is our base case. So when we will have recursive call for 1 comma 1, you can clearly return 0 here. Okay, what is the significance of 0? That is nothing but the value of kth position or at 1. Okay, at first position when k is 1, the value is simply 0. Okay, now since you are returning to the parent call, you will again start calling recursively by 2 comma 2, and then here, since you know the parent value or the value at kth position is nothing but 0, now you will check if k is at even position or odd position. Okay, if it is if k modulo 2 is equal to 0, what does that mean? This simply means it is at even position. That is, here when k is 2, so 2 modulo 2 is equal to 0 because 2 is even. Okay, so you can clearly see when the position is odd, the value is 0, but when the position is even, the value is reversed to 1. So when k is even, you will simply reverse the value. Okay, now let's look at the implementation. So yeah, before we move to implementation, first of all, let me tell you that we are back in the recursive calls with n equal to 2 and parent value equal to 0, because we have finished the recursive calls with n is equal to 1 and returned a value to the original call. So this is how the recursive function works, and it just keeps making recursive calls until it reaches a base case, and then it starts returning values back of the chain of recursive calls. Okay, now let's start. So as I first of all told you that there has to be some base case in order to make recursive calls. So what are we going to do? First of all, we'll simply check if n is 1. Okay, if n is 1, we are going to simply return 0, because it's clearly given in the question that we have to start by writing 0 in the first row. Now, after we are done with checking with the base case, so what are we going to do? We are going to find the parent position. So let's find our parent position, that is parent position of k, which will be nothing but it will be equal to k plus 1 by 2. Okay, now, so basically what have we done? We are just calculating the parent position using this formula, and it just helps us to identify the corresponding element in the parent row. Now let's identify or write the value of the value which is associated with the kth position. So it will be equal to, let's make a recursive call. Okay, with n minus 1 row and k or parent k. Fine, now we'll check. So we make a recursive call to the kth method, passing n minus 1 as the new row and parent k as the new position. Now let's retrieve the parent value. So we first of all store the value which is returned from the recursive call in the parent value, and it just represents the value in the parent row. Now let's determine, or let's check if k is even or odd. So if k modulo 2 is equal to 0, that simply means it is even, or k is even. So if k is even, we check the parent value. If it is 0, we return 1. If it is not 0, then we return 0. So what does that mean? That simply means if k is even, we check if parent value is 0 and we return 1, and if it is 1, we simply return 0. So basically, if k is odd, we return parent value as it is, because in case of even position, or you can say when k is even, you will have to reverse the value. If it is 0, you will reverse it to 1, or if it is 1, you will reverse it to 0. But when k is odd, that is when k modulo 2 is not equal to 0, in that case you will simply return the parent value as it is. Okay, so yeah, in the else case, let's return parent value. I hope you understand the question and the solution as well. So basically, in a nutshell, you can say this code uses recursion to efficiently find the kth element in the nth row of the pattern. Let's run the code. Okay, so the code is accepted. Okay, it's not accepted. Okay, so basically, run the code. So yeah, the code is accepted. Let's submit it. Okay, so yeah. So basically, in a nutshell, it just this code just uses recursion efficiently to find the kth element in the nth row of the pattern. It's a great example of how recursion simplifies complex problems, and it's important to note that this code accounts for various scenarios, including the base case, and this code is efficient, and it has a time complexity of big O of n, where n is the rows number, you can say, and it utilizes recursion to build the pattern. So please feel free to ask any questions or seek clarifications if any part of the explanation is unclear. Thank you so much for watching. Please stay tuned.